Hello and welcome to What, Why, When with Mr. N, where in this episode I'm going to be answering some of your science questions. Our first question in this episode is roughly how much DNA do humans share with chimpanzees? Well, the answer is that humans share about 99% of our DNA with chimpanzees. In fact, they are our closest living relatives within the animal kingdom. Oddly enough, humans also share about 60% of our DNA with bananas. All life on Earth is connected through DNA, tracking all the way back through the history of the Earth to where life began. Our next question is, in the bath, what makes your fingers prune? Well, we don't definitely know what makes your fingers prune, but the strongest theory for this is that your fingers wrinkle up to help you grip things when your hands are in water, and that this is part of evolution. If you look at tyres, you'll see that they've got a tread on them, lines cut into the tyre. This is to push the water away from the tyre. So when your fingers wrinkle up and you're using them underwater to grip onto things, the wrinkles will push the water away and it will give you a stronger grip. At least that's what the strongest theory is. What makes a teapot dribble? There are a couple of things which will make a teapot dribble. The speed that you pour at will affect this. The slower you pour, the more likely the tea is to dribble down the teapot. So you want to pour quickly, but you need to be careful that you don't overshoot the cup and pour tea all over the table. Also, the circumference and shape of your tea spout will also affect whether it dribbles. A thinner spout is less likely to dribble than a thicker spout. Now, you can try and stop your teapot from dribbling by using a substance which is hydrophobic, which means it repels water. Butter is a hydrophobic substance, but if you rub butter inside your tea spout, you're going to get greasy tea. Soot is also a substance which is hydrophobic, but again, if you rub that inside your tea spout, you're going to end up with soot in your tea. So right now, we don't have a brilliant fix for it, which isn't going to be very expensive. Why don't sheep shrink in the rain? The fibres of the wool on sheep have scales on them which all point in the same direction. So when they get hit by the rainwater, they come back up into shape, and because they're all in the same direction, they don't get stuck together. Sheep also produce a naturally oily substance called lanolin, which makes a sheep waterproof, and this also helps stop the fibres from sticking together. If you travelled at 55 miles per hour, how long would it take you to get to the sun? Well, the sun is about 93 million miles away. So we're going to need to do some division here to work out how long it would take us to get there if we travelled at 55 miles per hour. So take 93 million and we're going to divide that by 55. This gives us an answer of 1,690,909 hours. Now, if we want to know how many days that is, we need to take our 1,690,909 hours and divide that by 24, since there are 24 hours in a day. When we've done that, we'll see that it will take, if we round up, 70,455 days to get to the sun. So how long is that in years? Well, there's 365 days in a year, so take the 70,455, divide it by 365. That gives us an answer of 193 years, which is a bit longer than I would want to take to try and get to the sun. How long does it take the sun's light to reach the Earth? We've just spoken about the sun in terms of miles and how far away it is, but for this question I'm going to use kilometres because the speed of light is described in kilometres. The sun is about 150 million kilometres away, and light travels at about 300,000 kilometres per second. That means it takes a light from the sun about 500 seconds to reach the Earth, and that is around 8 minutes and 20 seconds. Could lightsabers be made using plasma, or would we not be able to wield them due to the plasma burning our hands? Interestingly, since Star Wars came out, people have been trying to deconstruct lightsabers to figure out how they could make one that works, and plasma has been a theory which has been put forward. Now, plasma is gas which has been heated up to very high temperatures. The problem is, two sets of plasma wouldn't clash like lightsabers, they would mix, unless you put a core up the middle of them. This is actually irrelevant though, because like the questioner hinted at, you would not be able to hold a lightsaber that is made of plasma, because the plasma is so hot you would end up causing severe burns to your hands. How long would it take the fastest spaceship to get to Pluto? For this question, I'm going to assume the questioner is asking about manned spacecraft, so I'm going to take the fastest speed recorded by any manned spacecraft, which was Apollo 10, which moved at 24,791 miles per hour as it travelled back towards Earth. Now, at its furthest distance from Earth, Pluto is about 4.67 billion miles away. At this distance, it would take 188,375 hours to get there if we moved at the speed of Apollo 10 at its fastest. That's about 7,849 days or 21.5 years. At its closest distance to Earth, Pluto is about 2.66 billion miles away. At that distance, it would take about 107,297 hours to get there, which is 4,471 days or 12.25 years. During the time that Britain was in lockdown, we've been going out on walks every day, and we've noticed that the sun is coming up earlier and staying up longer in the day. Why is that? To answer this question, we need to understand some facts about the Earth. Now, the Earth is a globe and it is spinning, and it takes 24 hours for the Earth to do a complete spin. That is what makes up a day. But the Earth does not sit straight up and down, it sits at a tilt of about 23.5 degrees. To demonstrate what's happening with the sun, I'm going to use a globe set up with a 23.5 degree tilt, and I'm going to use a torch. Now, during winter in Britain, where the questioner stays, we are angled away from the sun. So you'll notice here as I spin the globe round that we pick up the light from the sun later than other parts of the world, and it goes down faster than it does in other parts of the world that are angled towards the sun. Now, as the Earth orbits the sun, in the northern hemisphere, which was originally tilted away from the sun, we start to tilt more and more towards the sun, and in the southern hemisphere, they start to tilt further and further away from the sun. In the summer, Britain is angled at 23.5 degrees towards the sun. So in this demonstration, where we're angled towards the sun, you'll now see that Britain picks up the sun's light faster, and it picks up more of the light than other parts of the globe, and it loses it slower than other parts of the globe. Interestingly, when it's summer in Britain and we're angled more towards the sun, the Earth is actually at its furthest point away from the sun. It's just hotter for us in Britain because we're angled towards the sun. In the winter, when we are angled at our furthest away from the sun, the Earth is actually at its closest point to the sun, but we feel it colder because we're angled away, so we get less of the light and less of the heat from the sun. Well, that's all for this video. I hope you've enjoyed having your questions answered. If you have, like and subscribe and share the channel with your friends. If you've also got science questions about any science topic at all, then feel free to email me at stemwithmrn@outlook.com, and I'll get back to you with answers to your questions. And when I get enough through, I'll make another questions video. This has been What, Why, When with Mr. N, answering your science questions.